In this example, we're going to solve a rational equation. So step 1, find the LCD. Notice in the denominator, we only have one factor involved in this whole equation, and that is x minus 2, and in either denominator, it only appears once, so the LCD is x minus 2. Step 2, what do we do with the LCD? We're going to multiply all four parts of the equation by the LCD. Why do we do this? In order to get rid of the rational expression so that it will leave you with just a regular equation for which you solve for x. So you're only going to be canceling where you see a fraction or rational expression. So for example, the first term, you're not going to cancel anything there. But the second term is a rational expression, so you're going to cancel the x minus 2 on bottom with the x minus 2 on top. Anything on the side is the same thing as being on top. On the third term, we also have a rational expression that we can cancel out x minus 2 from the top and the bottom there. The fourth last term, there's no canceling there because that's not a rational expression. So once we cancel the x minus 2 there from the top and the bottom there, whatever we're left with again is a regular equation in which you solve for x. So to solve this particular one for x, the first thing I'm going to do is combine like terms on the right side. 7x plus 1x equals 8x. The next thing I'm going to do is get all my numbers on the left side and 0 on the right. In other words, put it in standard form so that I can utilize the zero factor property. So that would involve subtracting 8x from each side and then adding 2 to each side. So let's go ahead and do that. So once we do that, we're going to wind up with a trinomial, x squared minus 10x plus 16. Let's go ahead and factor that and then solve for x. So once we factor that, we can see that for one parenthesis, we're going to add 2, the other add 8. And that leaves us with two solutions of 2 and 8. After you get your solution, the next step is to always check to make sure that your solutions does not make the denominator undefined of any part of the equation, because if so, we have to discard or throw out that solution. So let's start by checking 2. And let's go up to our equation and into the second expression there. Let's remove the x and replace it with a 2. And what that will give us is 2 take away 2, which is 0. So once you get 1, 0, it doesn't matter if you have any other. It's automatically the whole equation would be undefined. And even though you see here for the third, it would make that a 0 as well. But even if it didn't make one or the other, as long as it make any part of it 0 on the bottom, then that is a solution you have to throw out. So we're going to have to throw out the 2. How about the 8? If we plug an 8 in where the x is, it is not going to give us a 0. So 8 is fine. We get to keep our solution. The only number that would make this one undefined is the 2. So we throw that out, and the solution to this equation is simply 8. And there you have it, solving rational equations.